So today I am going to give a lecture about addressing modes. What is that? So previously I have told about the instruction format. So today I will give on addressing mode. What is it? So basically what I will tell, that is it is a instruction format. At first there was an opcode, and here there is a address. So in opcode, what opcode tells? CPU tells that what operation you have to perform. Suppose I am assuming that I am doing increment operation. I will do increment operation. So for that I have used 1101. For the address I have taken 10. So address will tell that in where the operand is there. So that is the address. So addressing mode means what is the use of mode? What is the use of mode? Mode tells that in that the CPU, in which address CPU will get the operand. So that is the mode. Generally we know that in register we can get the operand, and in memory also we know that we can get the operand. For register, if the operation is increment, for the register there will be the operation will be I N C R 1. So if I get where the operand is there, that will be INC R1 in register, and if it is in the memory, then it will be INC memory 1. So this is how the operand are stored in case of registers and in case of memory. But if other than register and memory, the operand are stored, then how we will know that in which address it is stored or what type of address it is? So for that we need to send some extra bits to the CPU, that is only mode. So what is addressing mode? It specifies how and from where the operands are obtained from an instruction. So this is the mode, and what is the purpose of addressing mode? It is the purpose is that to give CPU flexibility in design, so that CPU can design in its flexible way. So there are different types of addressing modes: implied mode, immediate mode, direct mode, indirect mode, register mode, register indirect mode, auto increment or auto decrement mode, indexed or indexed register, then PC relative, and last is base register. So this one, from implied to register indirect, this one are the non-computable These are called non-computable. Where there is no addition, subtraction, it can perform. And the rest, that auto increment, auto decrement, PC relative, index base, these are computable. That means where we can do the computations. So in this, from implied to register indirect, these are non-computable when no computations are performed, and from auto increment to base register where the computations are performed. Now, what is implied? So, the opcode definition itself defines the operand. That means in the opcode we are having operation plus operand. So, in the opcode only we are getting the operation and operand. Just like increment INC A. So, what is this? Increment accumulator. Increment accumulator. So, here only you can get operation, increment and operand is that. So, this immediate mode is accessed when there is a special purpose resistance. In case of special purpose resistance only, implied mode is applied. Next is immediate. Immediate mode, the address field of instruction specifies the operand value. That means here only we will get the operand value. So immediate mode it is used to initialize the registers with constant value. That is only immediate mode. Then what is direct mode? Direct mode is also called as absolute mode. The address field of instruction specifies the effective address. Effective address means the address means the effective address refers that in which memory the operand is stored. That is the effective address. So this address field defines the effective address and we are getting the operand value. So only one memory access is there. Only one memory access we are having in this direct mode or absolute mode. Next is indirect. The address field of instruction specifies the address of effective address. Means here this one is not the effective address. From this we are getting the effective address and from this effective address we are getting the operand. So that is only the indirect. Here two memory references are required. Two memory references are required in case of indirect mode. Previously in direct mode there was only one memory access. This one is the effective address and there we are getting the operand. And in indirect we are getting the address of effective address, then we are fetching the operand. So mainly we are having two memory references. Now what is register mode or register direct mode? The address field of instruction specifies a register which holds the operand. So this is the register here. In separately register is there, and from this address we are fetching the operand, that is the register. Next, in indirect mode, the address field of instruction specifies the register which holds the effective address. So from here in this register we are getting the effective address and from effective address we are getting the operand value. So here one register and one memory reference is required. So here one register and one memory references are required for register in direct mode. In the case of register direct mode, only one register was required, but in case of indirect mode, we are having a reference of memory also to get the operand value. Next, what is auto increment or auto decrement mode? It is a variant of register indirect mode. It is a variant of register indirect mode in which the content of register is automatically incremented or decremented to access the sequential data. Sequential data means, for an example, I am giving, you have, for an example in program, we are having loop, means we are having loop for I equals to 0, I less than equals to 50, I plus plus. So we are taking 50 elements here, and then we are doing some operation on AI. Okay, so in this, what I have to do, in instruction format there will be opcode and here will be address. For what? Address for 50 elements. So we have to store the opcode value and also the address for 50 elements. So for that we are using this mode, that is auto increment or auto decrement. Let's say in register, if the base register means where the operand is stored, suppose 200, and the register value is also 200. Okay, so from the address we are fetching to register. In the register, what I have to do, suppose I am doing auto increment. And another thing also, in auto increment, in case of auto increment, we are doing post increment, and in auto decrement, we are doing pre decrement. Means what? Post increment, when we are using, suppose here it is 200. Okay, so I am fetching the value that is in operand 200. So here what will do, PC, in case of auto increment, it will be 201. After the operation is done, we have incremented the value to the next address, that is 201 for the auto increment. First I have done the operation, then we are incremented the value. But in case of auto decrement, it will be reverse. Means previously I have to decremented the value, I will decrement the value, then I will fetch for the operand. So from 201, then again it will go to address in where the operand is there, either there is or not. So 201, I am getting the operand 2. Again in auto increment, what we will do, 202. Again it will fetch to 202 address. So that is the working principle of auto increment and auto decrement. In case of index or index register mode, what is that? Base address taken from address field of instruction and index value from index register. Suppose I am taking an array, an integer value array of 5 elements. Integer value of array 5 elements, and for that I have taken one memory of 5 elements memory, and the base address I have taken 300. And we know that integer value must be 2 bytes. So 300, 302, So how to get the location or address of array 3. How to get the address or location of array 3. What is the formula for this? So formula is nothing. Base address. Base address means the address which is stored, which is in the memory, which is the first starting address is stored. That is 300. Base address plus W into W into 3. Why 3? 3 means in array 3. 3 element. Number 3. And W is the size of element is W, and 3 means this 3. Array number 3. So base address is 300. Base address is 300 plus size of the element is 2. I have told that integer value means it is having 2 byte. 2 byte. So 300 plus 2 into 3. So what will get? 306. So 306 is the value. You can see that in the array 3 we are getting the address 306. So then what is the formula? That is base equals to base, how are getting the address? Base plus W into I. I means for array I. Array I. If it is N, then we can write W into N. So this is the formula for index register. Index register, the formula is base plus W into I. Then we have got the index register. Then how we will get the effective address? So effective address will be, effective address is equals to base plus index. Base plus index. You can also write effective address as address part of instruction plus index value of register. So this address part of instruction, we will get the base from this, and from the index value register you will get the index. So by this way you will get the effective address, that is base plus index, address part of instruction plus index value of register. So that is index or index register. Base address from address field. From here we will get the base. From here you will get the base. Then you will add the index. You will get the value from index register and do the plus, and you will get the effective address. And from that effective address you will get the operator. That is only index or index register. Now, what is PC relative mode? What is PC relative mode? PC value is added in address field, that is value offset of instruction to get effective address. That means in opcode you are getting then mode, then address, then you are getting the value of PC, then target instruction. What is this? So first we have to learn what is branch instruction. Mainly PC is used for branch instruction. Mainly PC is used for branch instruction. So what is branch instruction? Let's know. What is branch instruction? Branch instruction means, for an example, in programming you have learned about loop, for loop, while loop, then switch case. All are this branch instruction. So first of all, this is the memory and here are the instructions. I1, I2, I3, I4, I5, I6, I7, I8 and many more. So this is the memory and we are having instructions. So what we take is this one is the program. A set of instructions is known as program. So for this we are having address, base address like 300, 301, 302, 303, 304, 305, 306, 307, 308. So in branch instruction we are having this memory, then these are the addresses and the set of instructions are the program. So in case of branch instruction, suppose the PC value, PC means the address of the next instruction. So PC, if the instruction for I2, suppose I am assuming the instruction for I2 is 301, means the address is 301. So PC will be 302. So PC will be 302. Now CPU is assuming that there is a branch instruction in I2. Okay, so there is a branch instruction in I2 and it is referring to I7. I am assuming that there is a branch instruction in I2 that is from I2 to I7. Okay, so what will branch instruction do? CPU will know that there is a branch instruction. That if the condition is true, if there is a branch instruction, means branch is taken. So the PC will be incremented again. Means PC will go to this target instructions. Means this one will be the target instruction. PC will come to target instruction, or this 306 will be the target address. And in case if the condition is false, then the next sequence instruction will be followed. Suppose if the PC is 302, that means it will be 302 only. No changes will be there in case if it is false. So if it is I2, then we are getting the target instruction I7. So what will be the value for this? The address will be 306, means the target instruction is I7, target instruction is I7 and the target address will be 306. Target address is 306. So target address, we are getting this 306 in branch instructions, means in the branching instruction, effective address is only the target address. So how we will get the effective address or target address? First base, first PC address means program counter value, which is updated, that is 302 plus how many number of memory locations I have skipped, means from I2 to I7 I have skipped the memory locations. How many? 1, 2, 3, 4. Okay, so PC plus 4. So PC value is 302 plus 4. What will be the value? 306. Okay, so the effective address is only the target address in case of branch instruction. So what will be the PC value? The PC I have got for I2 302 and then I am adding this 4. 4 means the number of memory locations I have skipped from I2 to I7. That is memory locations. This is known as the